Our galaxy's black hole went quiet 50 years ago, and apparently nobody noticed that it once roared so loudly it lit up clouds from the inside only a few hundred years ago, around the time Galileo was alive. If this sounds interesting to you, hit subscribe right now because we cover discoveries just like this every single day with no fluff attached. So let's talk about the black hole sitting at the center of the Milky Way, called Sagittarius A star. This is the object whose official picture many of us have seen, though we should be clear that the picture only shows radio light, stitched together from several frames. It's not something we'd actually see with our own eyes, but it's the best representation scientists currently have. Today, we're heading back to the center of the galaxy to look at a long-standing mystery, the strange silence of this black hole. Despite being roughly 4.3 million times more massive than our Sun, Sagittarius A star seems to emit almost nothing. It doesn't appear to produce powerful jets, it doesn't seem to have a large accretion disk, and it only occasionally lets out faint X-ray emissions, the kind that show up in images from the Chandra Space Telescope. Compared to black holes in most other galaxies, ours is unusually quiet. Because of this silence, astronomers expected to see something else instead, something that has been observed around black holes in other galaxies, which is wind. Every black hole that consumes material, even without producing jets, should still generate winds, simply from the interaction between gas and the black hole's gravity. But for nearly 50 years, astronomers found nothing of the sort. This absence of wind even led some scientists to wonder if maybe this wasn't a black hole at all, but something more unusual, like a clump of dark matter or some kind of exotic star-like object. The discovery of Sagittarius A star itself happened back in 1974 in a region of the sky called Sagittarius A, with the word star simply marking it as something peculiar. It actually took decades of work to confirm it really was a black hole. Researchers traced the motion of stars near the center of the galaxy, some moving at around 8% of the speed of light, and the only explanation was a massive hidden object pulling them into such fast orbits. For this work, Reinhard Genzel and Andrea Ghez won the Nobel Prize in 2020. Then, in 2022, we finally got an image of the gas surrounding the black hole, captured by the Event Horizon Telescope. Even so, this region remains very hard to observe, partly because it sits about 26,000 light-years away, and partly because a thick layer of dust and gas sits between us and it, blocking most of the light. Only certain wavelengths, like radio waves or X-rays, manage to slip through. Years of observation eventually confirmed that the black hole is currently in a quiet phase, not consuming much material at all. About a decade ago, though, researchers discovered something called the Fermi bubbles, two enormous structures of gas extending from the galactic center, along with a second set visible only in X-rays. These bubbles suggested that Sagittarius A star had a much more violent past, possibly a few million years ago, and is simply behaving quietly in modern times. Now here's the key finding. A new study led by Mark Gorski and Alina Morikova used the ALMA radio telescope in Chile, collecting over 100 hours of data across roughly 5 years. They developed a new technique for processing this data, making their images around 80 times sharper and 100 times more sensitive than anything seen before. The goal was to see if there was something hidden that earlier observations had missed. And apparently, there was. They found a cone-shaped cavity close to the black hole, sitting inside clouds of cold gas. This empty region stretches about 3 light-years and spans roughly 45 degrees, almost completely cleared of cold carbon monoxide gas. A void like this is extremely difficult to explain unless something very powerful blew it open from the center, and the most likely cause is hot wind streaming directly from the black hole. The researchers checked whether nearby stars could have caused this instead, but even combining the power of all nearby stars wasn't enough to carve out something this large. Based on their calculations, this wind has likely been blowing for at least 20,000 years, which tells us the black hole has remained fairly calm for at least that long. Alongside this, a separate study using a newer X-ray telescope called XRISM looked at molecular clouds near the galactic center and found what scientists call light echoes. This happens when a burst of light from a central source reflects off surrounding clouds of gas, almost like the clouds are acting as mirrors. By studying these reflected X-rays, researchers were able to pin down a moment when the black hole became dramatically more active. The data suggests that just a few hundred years ago, around the time Galileo was alive, Sagittarius A star flared up and briefly became about 10,000 times brighter than it is today. Back then, without X-ray observatories, nobody on Earth could have seen this happening, since it would have remained completely hidden behind dust, even with the best telescopes of that century. This flare appears to have shown up clearly within a molecular cloud known as G0.11-0.11, whose unusually strong emissions are difficult to explain in any other way. This matters because it reshapes how we understand our own galactic neighbor. For decades, the lack of wind made some scientists question whether Sagittarius A star was even behaving like a normal black hole. This new evidence confirms that it does produce winds and powerful outbursts, just like black holes in other galaxies, but right now it simply happens to be in a quiet resting phase, mostly because very little material is currently falling into it. Winds and emissions like these matter on a much larger scale too, because they can shape entire galaxies, sometimes even stripping away enough gas to stop new stars from forming altogether. Studying these effects near our own galactic center helps scientists understand similar processes happening in distant galaxies, and also gives us a glimpse of what might happen here when our black hole becomes active again someday. This kind of research also connects to bigger questions, like the idea of a galactic habitable zone, since radiation and winds from an active black hole could potentially strip atmospheres from planets located within a few thousand light-years of the center. That makes this relevant for astrobiology and for researchers searching for signs of life elsewhere. Fortunately, sitting about 26,000 light-years away ourselves, we appear to be safely outside that danger zone, so even a future outburst from Sagittarius A star likely wouldn't threaten us directly. We'd just get to observe quite a show. After 50 years of searching, it seems the missing wind has finally been found, and our black hole turns out not to be broken or unusual after all, just a supermassive black hole occasionally taking a very long nap between bursts of activity. So, with better telescopes and new techniques on the horizon, we'll likely understand this resting and waking pattern even more clearly in the years ahead, and maybe even learn to anticipate its next flare before it happens.